All right, today we're going to dive into a really powerful statistical tool. It's one that helps us find the hidden factors behind the data we see every single day. It's called multiple regression, and you'll see it's all about getting the whole story, not just that first obvious chapter.
So let's just imagine for a second you're trying to predict something. Anything, really. Maybe it's how long a project is going to take, what next quarter's sales will look like, or even just how long your commute will be. Your brain, it immediately starts hunting for clues, right? For predictors.
And you probably grabbed the most obvious one. More traffic, longer commute. Bigger project, more time. It just feels intuitive. But as we're about to find out, relying only on the obvious clue can be, well, incredibly misleading. To really see what I mean, we're going to look at a classic case study from the Butler Trucking Company. Their goal was pretty simple. They wanted to get better at scheduling their drivers by predicting their total daily travel time. Seems straightforward enough, doesn't it? So they started collecting data on 10 different driving assignments. And the most obvious clue, the one they started with, was the link between miles traveled and travel time. I mean, more miles should equal more time. It makes perfect sense. And yeah, if we just stopped here, we might build a simple model that says, for every X miles you drive, it takes Y hours. We'd probably call it a day and feel pretty good about our prediction. But that's exactly when the data is about to throw us a huge curveball. See, as we dig a little deeper, we find that this simple explanation has a massive hole in it, and it's a super common trap in data analysis.
When we look closer at the actual data, a real puzzle emerges. Take a look at trip 1 and trip 4. Both are exactly 100 miles, but one took 9.3 hours and the other took only 6.5 hours. Whoa! Our simple miles predicts time model just completely falls apart right here.
And this is the moment our simple model just breaks down. The same distance, but almost a 3-hour difference? Something else has to be going on. There's another factor, a hidden variable that's messing with the travel time. But what on earth is it? And here it is, the number of deliveries. If we go back and look at those two 100-mile trips again, we suddenly see it. The 9.3-hour trip had 4 deliveries, while the 6.5-hour trip only had 2. Every single stop adds time, totally separate from the miles driven. This was the missing clue. This mistake actually has a name. It's called omitted variable bias, and it is one of the most common errors you can make in analysis. It's what happens when we build a model but we forget a key ingredient, and that causes our understanding and our predictions to be just fundamentally wrong. So how do we fix this? How do we build a model that can juggle more than one clue at a time? Well, this is where our hero, multiple regression, comes onto the scene. So unlike simple regression, which only looks at one factor, multiple regression lets us use 2, 3, even more independent variables, things like our miles traveled and the number of deliveries, to get a much more accurate prediction of our outcome, in this case, the travel time. And this really gets to the magic of the whole technique. It can tell us the specific impact of adding 1 more mile to a trip while holding the number of deliveries steady. And at the same time, it can tell us the impact of adding 1 more delivery while holding the mile steady. It's like being able to isolate and listen to just the violin in a full orchestra. Okay, so let's actually apply this powerful tool to our Butler Trucking data and see what it spits out. What does the complete picture really look like? So the computer crunches the numbers and it gives us this formula. Now I know, it might look a little intimidating, but just think of it as a recipe. It's a recipe for predicting travel time. We just have to plug in our ingredients, how many miles and how many deliveries. So here's how to read that recipe. The model gives us a starting point, what's called an intercept. And yeah, it's a negative number here, which doesn't make a ton of sense in the real world, but it's just a statistical quirk that makes the rest of the math work out. So from there, for every single mile we travel, we add about 0.06 hours. And for every single delivery, we add almost a full hour, about 0.92 hours. See, now we're accounting for both things. So the big question is, how much better is this new recipe? Well, the answer is measured by something called R-squared. And for our new and improved model, it's over 90%. That's huge. What that number actually means is that our 2 variables, miles and deliveries, can now explain over 90% of why the travel times are different. We went from a confusing puzzle to an almost crystal clear prediction, all because we found and included that one hidden variable. Now, multiple regression is an amazing tool, but like any tool, you gotta know how to use it right. So let's quickly touch on a couple key ideas for using it wisely.
First, you have to be careful not to include variables that are basically measuring the exact same thing. That gets a fancy name, multicollinearity. And second, what do you do if your data isn't even a number? What if it's a category, like say, type of repair? Well, it turns out there's a really slick way to handle that too.
We do it using something called a dummy variable. All we do is turn the categories into numbers. So for example, in this other data set about repair times, we can just code all mechanical repairs as a 0 and all electrical repairs as a 1. Now the model can actually understand and use this information.
And what's so cool about this is that it basically creates two separate prediction models inside of one. You can see it right here. The model gives us one equation for mechanical repairs and a slightly different one for electrical repairs. It figures out that, A, maybe electrical repairs just have a different starting time, and it builds that right into the prediction. It's incredibly flexible.
And this all brings us back to that central idea. As the source material points out, just failing to account for these other variables is one of the biggest mistakes people make when they're trying to understand the world with data. It's the difference between a shallow guess and a really deep insight.
So the next time you hear a simple one-cause explanation for some really complex problem, remember the Butler trucking puzzle. The most important clues are very often the ones you aren't seeing yet. The only question is, what will you go looking for?